We're starting our factoring lesson. Factoring is really a fancy word for dividing. So what we're doing is the reverse of our distributive property that we just looked at on our last lesson. The different types of factoring include GCF factoring, which is finding the greatest common factor. What goes into all of the terms, and then you divide it out. Second is difference of squares, and this is when you factor something into conjugates. So remember when we rationalized the denominator with a radical, we multiplied by the conjugate, and we got to skip multiplying the inside and the outside because they canceled each other. The difference of squares is what was left after we multiplied the two conjugates. Sum or difference of cubes is probably the one that you'll need the most practice with. Hopefully you got an introduction to it in Algebra 2, and we'll see this formula over and over. Hopefully it sticks in your mind. And finally, there's the T-chart factoring. T-chart is simply factoring it into binomials. So let's remind ourselves of why the T-chart factoring works. This middle term is the sum of the -8 and 4. That's the inside and the outside. The x times 4 minus 8x gives us a sum of the -4x. The -32 is the product of the -8 and 4. So that's the last terms. The -8 times 4 gives us the -32, and of course the x squared comes from the x times x. This next page just gives you some steps to follow as you're factoring. The first thing that you always want to look for is a greatest common factor. Pull that out first. It'll make what's left easier to factor. And then look for those patterns. Look for difference of squares. Look for sum or difference of cubes. And finally, if you have a trinomial, you'll factor using the T-chart method or the AC method, which we're going to get into tomorrow. Starting with some difference of squares, again, first thing that we want to look for is if we have a greatest common factor. In this case, x squared and -81 have no common factors, and we recognize it as a difference of squares, so we factor it into conjugates. The square root of 81 is 9, so that's how we figure out what numbers to use. Again, thinking about multiplying this out, we get x squared minus 81, and when we do those inside and outside, we get -9x plus 9x, which cancel. So that's, again, why the difference of squares works. Next one, we have another difference of squares. Again, no common factor on this one. So we take the square root of 1, plus or minus order does not matter. Square root of 49 is 7. Square root of y squared is y. And then we write the conjugate. Next, we do not have a difference of squares. 12 and 27 are not perfect squares, but they do have a common factor. So we're going to factor that out. -3 is what I want to factor out. I always like my first term to be positive. It's easier to organize our work. So I'm factoring out the common factor of -3, leaving me with 4x squared minus 9. And then what's left in the parentheses is a difference of squares. So we're going to take the square root of everything. Again, order doesn't matter if you choose to put your positive one first, as long as you factor that difference of squares into conjugates. This last one may not look like a difference of squares, but it is. This whole term is squared. So the square root of that would be 2x minus 1. Square root of 25 is 5. And then write the conjugate. Now this is the first term, so we're not going to make this a conjugate. That is the square root of the first term. The 5 is what's going to become opposite. So this is one way to express our answer. We can also simplify it by dropping those parentheses and combining our like terms. So we've got the 2x minus 1 plus 5 gives us a plus 4. And then the 2x minus 1 minus 5 gives us a minus 6. Next, we're going to review factoring trinomials. Again, remember this is that T-chart method. So when we set up our T-chart, we figure out what multiplies to the constant, that is the number without a variable piece, and adds to the middle term. The x squared we know is going to be x times x, so we don't need that in our T-chart. Two numbers that I think of right away that multiply to 12 are 4 times 3, but when we do 4 plus 3, that gives us a 7. Of course, a negative 4 times negative 3 also multiplies to a positive 12, and the negative 4 plus negative 3 adds to the negative 7. So once we find the two numbers that work, we simply put them into our binomials. Again, for checking, there's no reason you should ever get factoring incorrect because you can always multiply to check your answer. X times x gives us that x squared. Negative 3x minus 4x is the negative 7x. And negative 4 times negative 3 is positive 12. Same process on this one. Variable does not matter, so we're multiplying to negative 10 and adding to a positive 3 this time. So I know that when I'm multiplying to a negative, I need one positive and one negative number. So I'm going to try 5 times negative 2, and of course 5 minus 2 gives me the 3. So I factor those into the binomials, y plus 5, y minus 2. This one I see a GCF. All three of these terms have a negative 3 in common. When you're doing the T-chart method, if the leading coefficient is not positive 1, you cannot use the T-chart. So I have to factor out the negative on this one. So I have m squared minus 4m minus 5. Setting up my T-chart, what multiplies to negative 5 and adds to a negative 4. The only numbers that multiply to 5 are 5 and 1. So I need to figure out which one needs to be negative. Because the answer when I add is negative, my greater value needs to be negative. When I continue factoring, I have to keep that GCF. My final expression must be equal to the expression that I started with. And if we drop that GCF, it will no longer be equal to the original expression. So make sure you keep that common mistake as students want to drop that GCF once they continue factoring.